Okay, this is Chapter 10, Lecture 7. Chapter 10 is titled Calculation of Medication for Special Populations Based on Body Weight and Patient Age. And so far I have, within Lecture 6, I started off by first teaching you guys how to determine a patient's body surface area. Remember, the body surface area is the most accurate method when it comes to calculating doses for patients within special populations. And the reason being is because the body surface area consists of two components, the patient's weight and the patient's height. Now, when determining the body surface area for a patient, you can either determine that by using what they call a nomogram, which gives you an approximation of the body surface area, or you can determine the body surface area using one of the two body surface area formulas. And so that is what we have done in practice problem C. All right. So now what I want us to do is I want us to now determine the dose ordered based on using the body surface area method. So in order to do that, the best thing to do, you guys, is let's just do some practice problems. So let's look at let's do some examples. Let's look at example 10-6 at the bottom of page 360. All right. And it reads that if a physician orders Cytoxin 50 milligrams per meter squared per dose IV for an adult who is 55 inches tall and weighs 160 pounds, what dose should be given? Well, the first things first, within this example, you're going to pull out the information that you need. So the information that we have so far is that the patient is 55 inches tall and is what? 160 pounds. I'm going to write this a little more neatly. They're 160 pounds. Okay. It tells us that the order is 50 milligram per meter squared per dose. All right. So based off of this information, this is where you guys ask yourself, the very first question you ask yourself is, looking at the information, does the patient's info match the order? That's the very first question you ask. The patient's info is in inches and pounds. The order is in milligrams per meter squared. So the answer to that question is no. The patient's info does not match the order. The patient's info should be in meters squared, which means you must find the body surface area. So that's step one. I'm going to pull up another page so you guys can see. So step one is we're going to find the body surface area. So for step one, find body surface area. In order to do that, you're going to use one of the two formulas. Since the patient's information or their height is in inches, we're going to use the body surface area formula where we take the square root of inches, 55 inches times their weight in pounds, which in this case is 160 pounds. And you're going to divide that by 3131. So far, I've set the problem up correctly. So if you take 55 times 160, I'm going to do this step by step. You have, let's just make sure that my calculations are correct. 55 times 160, you get 8,800 divided by 3131. Well, when you divide that by 3131, you get, in your calculator, you should get 2.81060364, and it's a long number, so I'm just going to put some dots there to indicate that it's a long number. All right, you're going to take the square root of that entire number. So when I take the square root of that entire number, I get like 1.676485. Again, you have to make sure that you round your body surface area to the 100th place, so your final answer should be 1.68 meters squared. All right? So that should be your answer for the body surface area, is what? 1.68 meters squared. So you've basically determined what the body surface area is, but you have not yet determined what the dose order is. You've basically just made sure that the patient's information matches the order. Because you've changed the patient's information to body meters squared for body surface area, it now matches the order. So now we could go ahead and solve the problem. Well, step number two is using the body surface area calculated. You can solve the dose order by using the body weight method. What do I mean by that? Okay, so now that you know that the patient has a body surface area of 1.68 meters squared, you now are going to multiply that by that order of what? 50 milligrams per meter squared. As you can see, meter squared crosses out. So now all you need to do now is take 1.68 and multiply it by 50. And your answer is 84 milligrams. That is the dose ordered. That is how much the patient should be receiving, which is 84 milligrams of this medication. If you look at it step by step within your book is going to give you quite a different number, because they're using the nomogram to determine the patient's body surface area, which gives you an approximation instead of using the body surface area formulas that will give you the exact body surface area for that patient. All right. Okay, so the next question within example 10-6, the next question that it is proposing to us is that if they want to know if the medication is available available in 200 milligrams per 10 milliliter, what would the volume be? All right. This is actually just on page 361, right above example 10-7. So in order to calculate this, what they're basically asking you is, what is the volume per dose? They just want to know how many milliliters per dose will provide that 84 milligram dose order. Well, in order to calculate that, you're going to use your formula method where you take dose order over dose available times the quantity. Your dose order, you guys calculated that to be 84 milligrams. The dose available is what's in stock, which is 200 milligrams. And you're going to multiply it by the quantity of 10 milliliters, which is associated to that 200 milligrams. Milligrams cross out. So 84 divided by 200 times 10. The volume per dose is 4.2 milliliters. That is how much the patient should be receiving. If you look in your book has your answer as 4.4 milliliter. This is why it's very important that your body surface area is correct, because if it's not, it increases your dosages, which means that you're overdosing the patient. Remember, your book is using the nomogram as an approximation. We're using our actual body surface area formulas to calculate the exact body surface area for each patient. All right, that is the end for lecture 7. I'm going to pick back up in lecture 8 with a few more examples. Again, if you have any questions, please send me an email.